Hello everyone, welcome to this next video on complex analysis. So here in this video we shall see again a question from GATE 2004 consisting of 2 marks. The question says, in the Laurent series expansion of this function, valid in the region modulus of z greater than 2, what is the coefficient of 1 upon z square in the Laurent series expansion of this particular function? So here one should note that we are given this region modulus of z greater than 2, strictly greater than 2. So that means we are interested in finding, in order to find the Laurent series expansion, you should have terms like this 1 plus z raised to power something n type, so that we can apply the binomial expansion onto this. The condition here should be that the modulus of z is less than 1. For that, what we have to do, we are given this particular region, so we'll make use of this condition. So let us see how we can solve this question. So we are given f of z to be 1 upon z minus 1 minus 1 upon z minus 2. So here, if from the first term I take z common in the denominator, so I would be having 1 minus 1 upon z, and similarly if I take z common from the denominator in the second term, I would be having 1 minus 2 upon z. So now look at the condition. The condition is given to be modulus of z greater than 2. So now if modulus of z is greater than 2, that obviously implies modulus of z is greater than 1 also, right? And if you take the reciprocal of these two, you'll end up, or you can shift this term to the right hand side, so you'll be having 2 upon modulus of z less than 1. And similarly in this case you would have 1 upon modulus of z less than 1. So we have a condition of this kind onto these two terms. So we'll make use of these two terms, and now you see in our expansion or in our expression we have these two terms over here. So we can just rewrite these terms in this form. So I have took this z common from both of these terms. So now in the first term I have 1 upon 1 minus 1 upon z. So in effect I can write this to be 1 minus 1 by z raised to power minus 1. And similarly in the second term I can write this to be 1 minus 2 upon z raised to power minus 1. So now I can simply apply the expansion of this term. So we have this expansion 1 minus z raised to power minus 1. This is equivalent to 1 plus z square and so on, right? So this is the expansion. So we can solve this. So let us see what do we obtain. So from while solving this first term, I would have 1 plus 1 by z plus 1 by z square plus 1 by z cube and so on, right? And similarly in the second term I have 1 plus 2 by z plus 2 by z whole square plus 2 by z whole cube and terms so on, right? So we can simplify this a bit. This 1 and 1 cancels, so the terms having this term 1 by z, the coefficients of this term 1 by z, that would be 1 minus 2, and then the coefficient of 1 by z square, that would be 1 minus and 4 and so on, right? So we can solve this thing. So we would have minus 1 by z, and then here you would have minus 3 by z square and so on. So when you multiply z inside, so you will be having minus 1 upon z square and minus 3 upon z cube and terms like this plus so on, right? Or minus so on. So finally in the question they were asking you what is the coefficient of this term 1 by z square. So here the coefficient of 1 by z square, that is simply minus 1. So this is the coefficient of this particular term. So the coefficient of 1 by z square, that is equal to -1. So let us look at our options. So from here, option A comes out to be the correct option. So well, that is it for this video. Thank you for watching.